Hi students, this is Alex here. In this video, we are going to find the half-range Fourier sine series for the given function f of x, which is sine ax in 0, L. The expansion formula is f of x equal to, we have summation n equal to 1 to infinity bn sine n pi x by L. And to find bn, we use 2 by L integral 0 to L f of x into sine n pi x by L dx. So we're going to replace f of x, which is given in the question as sine ax into sine n pi x by L dx. So usually we write the n term as the first term, so I'm going to rearrange this 2 by L integral 0 to L sine n pi x by L into sine ax dx. Now we have a basic trigonometric formula. When you have sine x into sine y, this is minus 1 by 2 cos of sum of the angle, which is x plus y, minus cos of difference of the angle, which is x minus y. So here this entire term is x, this entire term is like y. So when we apply this, we are going to get 2 by L integral 0 to L minus 1 by 2 cos of sum of the angle, which is n pi x by L plus ax, then minus cos of n pi x by L minus ax, then we have dx. Now we're going to integrate this, but before that we can take the x common. We can cancel these two. So minus 1 by L integral 0 to L cos of n pi by L plus a into x. Similarly, minus cos of n pi by L minus a into x. Then we have dx. Now we are going to integrate this. So minus 1 by L, integration of cos is sine. So sine n pi by L plus a into x whole divided by n pi by L plus a. We have to divide by the coefficient, minus sine of n pi by L minus a x by n pi by L minus a. And we have the limit from 0 to L. We are going to substitute the upper limit. When we substitute the upper limit, we get sine n pi by L plus a into L whole division n pi by L plus a. Similarly, minus sine of n pi by L minus a into L whole division n pi by L minus a. When I put the lower limit, because of sine 0, all the term becomes 0. Now we are going to multiply this L inside of both, so that it becomes sine. When I multiply, it will become n pi, because LL gets cancelled, then it is AL whole division. Here n pi by L plus a. Similarly here sine n pi minus AL whole division n pi by L minus a. Now we are going to expand this. When I expand using sine x plus y formula, this is sine x cos y plus cos x sine y. So this is like x, this is like y. So this is minus 1 by L sine x, so sine n pi into cos AL plus cos n pi into sine AL whole division. We have n pi by L plus a. Similarly minus, so here let's open bracket. So sine n pi into cos AL minus cos n pi into sine AL. Then for this whole division, we have n pi by L minus a. Now Wherever sine n pi is there, we can put it as 0 because sine n pi is 0. So these two terms are 0. So we get minus 1 by L. We left with only cos n pi sine AL division n pi by L plus A. And when I take this minus sign inside, this will become plus cos n pi into sine AL whole division n pi by L minus A. Now the common terms we can take outside the integration, which is minus cos n pi into sine AL whole division L, and here we have 1 by n pi by L plus A plus 1 by n pi by L minus A. We can take LCM, and before that there is a minus sign. Cos n pi is minus 1 whole power n into sine AL whole division L. Now we can take LCM. LCM is the product of these two terms, n pi by L plus A into n pi by L minus A. So here it is n pi by L minus A plus n pi by L plus A. After cancelling these two, we get 2n pi by L. So this is minus 1 into minus 1 whole power n. Then we have sine AL whole divided by L. This is 2n pi by L whole division. This is like A plus B into A minus B form. So we can use identity A square, which is n square pi square by L square minus A square. So the denominator part we can take LCM. So this is going to be minus 1 into minus 1 whole power n into sine AL by L, and this is 2n pi by L, and in the denominator the LCM is L square. So we have n square pi square minus A square L square. So after this L and L become L square, we can cancel with this. So the terms left out is minus, we can keep 2n pi and minus 1 whole power n into sine AL in the numerator and whole division by n square pi square minus A square L square. So we got Bn, and if we want we can combine this minus sign and this minus 1 whole power n, because this minus sign is minus 1 whole power 1. So this is minus 1 whole power 1. So we can add the power. So 2n pi minus 1 whole power n plus 1 into sine AL whole division n square pi square minus A square L square. So after getting this Bn, we can substitute this in the f of x expansion. So f of x already we have written in the first step. So we are going to substitute now. F of x is equal to summation n equal to 1 to infinity Bn. Bn is 2n pi into minus 1 whole power n plus 1 into sine AL whole divided by n square pi square minus A square L square into sine n pi x by L. And if you want, we can take the constants outside. The constants present here are 2, then sine AL and even pi. So it is better, we can write 2 pi. So 2 pi sine AL is constant. Then we have summation n is equal to 1 to infinity. After taking 2 pi, we have n, then minus 1 whole power n plus 1 by n square pi square minus A square L square into sine n pi x by L. This is the required Fourier series expansion, that is the half range sine series expansion for the given function f of x.